Great to come your way once again. In our previous lesson, we have looked at how we can determine the nature of quadratic equations. And we mentioned that to determine the nature, we must consider the b squared minus 4ac parts within the quadratic equation. And when we realize that it is greater than 0, then the nature of the roots of the quadratic equations are real and distinct. When it's equal to 0, they are real and equal roots. And then when it's less than 0, they are complex roots. My name is Nana Yawedu, and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that I can get all videos on time. In this lesson, we want to consider rational functions. We want to look at functions that are of the form f of x is equal to p of x all over q of x, right? And rational functions are things that we have looked at earlier when we looked at functions. So we want to look at rational functions, and basically we want to consider the operations on rational functions. So let's consider this. So when we are considering basic arithmetic operations involving rational functions, the way to perform it is that we must ensure that we can factorize both the numerator part and the denominator part where it is applicable. And then we can do this by cancelling out the common factors that we get. So let's look at some examples. So there are some examples here. We have to simplify the following expressions, right? In the first expression we have 3x minus 6 all over x squared minus 4, right? And we have the second one, which is 5x squared plus 5 all over x squared minus 4x minus 5. And then we have the quadratic equation as the numerator, 2x squared plus x minus 6, and the denominator 2x squared minus x minus 3. Now let's look at how we can solve these questions. So basically, to solve these questions, let's consider the I part of the question. So the I part of the question says that, right, we have 3x minus 6 all over x squared minus 4. Now, when we consider the numerator part, we can factorize 3 out. So when we factorize 3 out, we get x, right, minus 2. So when we multiply 3 times x, it gives us the 3x here. When we multiply 3 times 2 with the negative, it gives us the negative 6 here. Now, the denominator part, we can write it as the difference of 2 squared. So we can write it as s squared minus 2 squared, right? And then we can write it as 3x minus 2, right, all over x minus 2, the difference of 2 squared, s plus 2. So now we see that we can cancel out the factors x minus 2 and x minus 2. So that our final answer, we get 3 all over x plus 2 as a simplified form of the expression, right? So now let's consider the II part of the question. So basically for the II, we've been given an expression with numerator, right? So the numerator given in the expression is 5, right? X squared plus 5. So we have 5x squared plus 5. And then the denominator is s squared, which is a quadratic equation, minus 4x, right, minus 5. So we can factorize 5 out in the numerator, so we have 5, right? So we can have s squared, right, plus 1. And then the denominator part of the question, we are going to use our equation, right, or finding our quadratic equation. So we can use the calculator because there will not be any marks given for working out the values. So when we use the calculator, we realize that when we go to mode, we go to equations, and then we pick the equations that is of the form as squared plus bs plus c. Put on the coefficient of the x squared, which is 1, that of the x, which is minus 4, and that of the constant, which is minus 5. We realize that the values of x will be equal to -1, and x will be equal to 5. So therefore, we can move the -1 across the equal sign, or we can probably say we are adding 1 to both sides of the equation. So we get one of the factors to be x plus 1, right? And then we get another factor to be x minus 5. Right, so in this case, we realize that when we look at it, we can't do anything here in the numerator part so that we can simplify it. So we'll have to leave our answer as 5x squared plus 1, right, all over x plus 1, right, x minus 5. So there are no factors that we can actually divide the numerator and the denominator by. So we actually leave the answer as 5, right, bracket s squared plus 1, all over s plus 1, x minus 5. Now let's consider the third question. So with the third question, we've been given a quadratic equation or a rational function with the quadratic equation as the numerator, 2x squared plus x minus 6, and the denominator 2x squared minus x minus 3. So using the calculator, when we go to mode, we go to equations and pick equations that are of the form as squared plus bs plus c, and then we input the coefficients of the x squared, that of the x, and that of the constant for the numerator part. We realize that we get the values for the numerator part, right, to be equal to x is equal to minus 2, and then x is equal to 3 over 2. Now we can move the minus 2 across the equal sign, and the negative become positive, so we have s plus 2 as one factor, and then here we multiply 2 by 2, right, to get 2x is equal to 3. Then we move the 3 across the equal sign to get 2x minus 3. So our numerator part will be x plus 2, right, and then 2x minus 3. Then let's consider same for our denominator. So using the calculator, going to mode, going to equations, and then picking the equation that is of the form as squared plus bs plus c, and then punching the values for the x squared, which is 2, the s, which is negative 1, and then a constant negative 3. Realize that in this case, we will have x to be equal to negative 1 and x to be equal to 3 over 2. So we get x plus 1 as one factor, and then we get, right, so this is the same as this, so we get 2s minus 3 as another factor. So the denominator part here becomes x plus 1, then 2x minus 3, right? So we see that we have like factors that we can divide. So we have 2x minus 3 for the numerator part, and then we have 2x minus 3 for the denominator part, right? So this is done rough work. So now we can cancel out these, and then it gives us a simplified form as s plus 2 all over s plus 1. So rational functions can be simplified, right? We can go through the process of factorizing, and then once we are able to factorize, we can divide the common factors so that we can simplify it. So in this lesson, we have basically simplified rational functions by using the factorization method, factorizing the numerator part of the equation, factorizing the denominator part of the equation, and cancelling out the common factors. In our next lesson, we want to consider how we can perform basic operations of addition and subtraction of rational functions. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.